Hi, chemistry. Aninga here. I wanted to show you some examples of how to balance equations just in case you are totally lost on how you would do that. Um, so I have a couple examples that we can go through together. Uh, First of all, the ones that I have are varying like what they are in degree of hardness. So I'm going to start with one of the easier ones first. Let's start with this one right here. So the thing that balancing equations is all about is making sure you have the same stuff on one side of the arrow as you do on the other, on the opposite side. And it's all about taking inventory of what you have. So what I'm going to do is I'm going to see what's on each side here to decide what I need to put in each of these blanks. Okay? So on our reactant side, we have phosphorus, okay? And according to this molecule, we have 4 of them. And then oxygen we have over here, and we have 2 oxygen. And with how they're laid out, we can only add them in these proportions, in proportions of 4 and 2 respectively. 4 for phosphorus and 2 for oxygen on this side. On our product side, we have a separate compound that contains both of those elements. So phosphorus on this side, we have 2, and oxygen, we have 3. Now, on this side, we can only add more of these if we need them. Okay? So what you need to do is you need to make sure that these numbers for these elements are the same as the numbers over here for these elements. Okay? So, according to this, start with something that has the largest number first to see if you can't fix what you need to right away. So notice we have 4 here. We only have 2 phosphorus on the product side. So we have 4 on the reactants and 2 on the products. We need 2 more. We can only add in increments of 2. So right now we have one of these compounds, one molecule of them. If we added another compound, as we have a 2 here, that means we have, P times 2 and O times 2. This means that we now have 4P and 6O. This looks pretty good, but this doesn't. So we want to try and get this to 6. We can add numbers of O2 molecules. So if we add another O2 molecule, if it's a 2, that's timesing this by 2. It changes to 4. That's not good enough, right? We need to add another O2 molecule so that our O goes to 6. So this, instead of 2, goes to a 3 when we add another one. And now you look at your O's again and you see that they're both 6. We got 4 On this side, notice we didn't have to change anything. That means there's a 1 here. There's only one molecule of P4. And then we have 3 O2s to get 6 here to get 2 of these molecules. Again, the amount of each element should be the same on each side of the arrow. These numbers will be different depending on how you get those numbers, okay? So this would be the answer for this one, which is 1p4. This 1 doesn't technically need to be there, but I'm just showing you that there's one of those molecules here, okay? So there's 1p4 plus 3 O2 molecules, which equals 2 P2O3 molecules. Okay. Let's try another one. Here we have, as you can see, a double replacement equation. Here's our arrow. We'll divide that down the middle to separate our reactants and our products. Now you don't have to label those, it just helps me out. Sorry about that. And now we're going to take inventory of what we have so that we can easily determine what we need. So some of you can do this by mental math, others need to see it. I like to see it, so we have sodium, and we have 3 of those. Now, this right here, you should hopefully recognize is phosphate, a polyatomic ion. And notice it's in the same form here as it is over here. So you can actually count that as an entity instead of doing phosphorus and oxygen separate. It just makes it easier to count this as a piece. So we technically have only one of those. We have potassium, one of those. And then again, we have this OH, which is another polyatomic, that's hydroxide. Hopefully you should realize that. This is why I tried to drill those last section, because they're important to recognize by themselves. Notice it's the same here as it is on this side, so you can use that as an entity, and we have one of those. On this side, we have one sodium. We have hydroxide, which is only one of. We have K again. We have potassium again, which looks like there's 3 of those. And with phosphate, there looks like there's one of those again. Okay. So now we have to recognize what's different among these and what we need to do to change it. So we'll notice right away, sodium, we have 3 of them here, but only 1 here. And then here we have 1 potassium versus 3 on our product side. So what we want to do, we want to notice that here we have to add in like groups of like Na3, PO4. So if we add 1 and make this 2, that changes this to 6. Okay, we don't want that. Here, we want to try and get this to 3. So the easiest way to do that is to put a 3 here. That changes that to 3. And it changes hydroxide to 3. Okay, that changes that to 3. Now we need to go back over here. So Our Na is good. Na is good for now. OH isn't. So we can try and change that. We need 3 of them, so try having a total of 3. That changes this to 3. But that also changes our K to 3. Stop. Take a look at what you got. Your K is 3. K is 3. That's good. OH is at 3 now, and OH is also at 3, so that's good. And nothing happened to phosphate. That's still 1, so we're still good. If all of these match up, that means that this is balanced. So there's only 1 of these, there's 3 of these, 3 of these, and 1 of these. Again, this is all about taking inventory and trying at first, and then trying to see what you can add to make these numbers here the same on both sides of the arrow. Okay. Last one. Okay. We got our reactants and our products. Let's take inventory. We have carbon. Looks like we got 3 of those. We got hydrogen. Which is 6. And oxygen, which looks like 2, but we have to remember there's this one here as well. So we actually have 3 oxygen. So we have 1 plus 2 oxygen on this side. Over here on this side, we have 1 carbon, 2 hydrogen, and 3 oxygen. 2 here and 1 here. So notice this one's a little bit more difficult, this combustion reaction, right? Because we start off with 2 things. One of them is oxygen, and we get carbon dioxide and water out of it. Don't forget that. Combustion ones are tricky. But anyway, notice this one's a little bit different because we have oxygen split up in between 2 different molecules on both sides. So we have to keep that in mind when we're trying to balance. But first, let's look at one that we have. We can either change carbon, or we can change hydrogen. We can try hydrogen first since it is the largest at 6. And you can make 6 easily over here. You can add in increments of 2 hydrogen. So 2, 4, 2, 4, 6. So we need a total of 3 water molecules to make that 6. That changes to 6. That's 6. So, but that changes this O here to 3. So instead of 3 here, and a total, we have 2 plus 3. So now we have 5 oxygen. And that just won't do because this is changed. Okay. So that looks a little bit strange. So what we should do is try and change our carbon over here as well to try and accommodate this 3. Make this a 3. This changes carbon to 3. But it also takes and times this O by 3. So now instead of 2 plus 3 to get 5, now we have 3 times 2, which is 6, plus 3. Now we have 9 oxygen. So right now, this is fine. This C is fine. Okay? What we need to do is try and figure out how we can go from, so these 2 are fine right now. Don't change these yet. What you have to figure out is how you can get this 9, like get this 3 to 9. And knowing that O is right now 1 plus something to get 9, because we have a 1 over here, plus however many O2s that you want to add in here. Because we don't want to try and change this. So this should hopefully be easy enough for you to realize that how many we need here should be times 2, because we have 2 O2s. We can add in increments of 2. How can we get 8? Because 1 plus 8 is 9. So this number here should be 4. So if we do that, now we have 1 oxygen on here plus 4 times 2 oxygen, which is 8, which equals a total of 9. So then this is the answer to this one. 1 of these, 4 oxygens, which gets you 3 carbon dioxide and 3 water molecules. Okay? This is how you do balancing, so I hope that helps. Let me know if you have any other questions or want me to do other examples, and I would be happy to do that, okay? All right. Talk to you later, everybody.